Okay, hi, how you doing? What we're going to talk about today is something called completing the square. And the reason we use completing the square is for multiple facets of reasons, but I like to use completing the square because I think it's easier to solve for a root of a function using completing the square than it is actually to use a quadratic formula. And if your teacher has ever shown you, quadratic formula is derived from completing the square on a quadratic, actually, in standard form. So the purpose of this video today, though, is just to talk about how it is that we use completing the square. First things first, let's talk about all our perfect squares. So the two perfect square formulas we have are we can have some value plus another value and say in this quantity we could square it, or we could have the subtraction of two quantities and then square it. Okay? And just to use some basic numbers here. So let's say we had 4 plus 2 and that quantity squared. Right? We really wouldn't apply this formula to this, but just to show you that it works, that you should all know that 4 plus 2 is 6, and 6 squared we would know is 36. Okay? But just to show that this formula works with just numbers as opposed to the algebraic stuff, so if we take a look at this, if you would square, okay, this is A, so squaring 4 makes 16, and you add on to that plus, so multiply A and B together, so 4 times 2 is 8, and then multiply it by 2. Well, 2 plus 8, okay, 2 times 8 is 16, so we add 16 on here again, okay, and then we square B, so 2 squared is positive 4, so plus 4. And what you notice here is that 16 plus 16 is 32, and 32 plus 4 is 36. So just showing you this with numbers, that this actually applies and holds true. So now what we can start to do is we can start to think about inserting variables. And the importance of this idea for completing the square is that now that we start to insert variables, what we need to show is that these A's and B's or whatever could just be placeholders for some variable that if we did know it, then it would obviously give us an answer to that square number. So, for instance, let's say we have an expression, okay? And the expression happens to be x squared plus 5x. And I want to write this as a perfect square. Well, it's missing something. And it's missing its b squared. So if I compare this, okay, to this formula up here, okay, so I have x squared plus 5x. What I'm going to compare it to is actually this one up here, because in this quadratic, okay, this happens to be, if I take a look at this, a squared plus this 2ab, okay, plus b squared. For me to write this as a completed square, what I need to have here is I need to have the b term, because if you notice that a, okay, just so happens to be this value of x squared. So the a here is my x, is the x value, and in here this 5x is also replacing the a. So if you take a look here, what I already have is that I've got this a. So if I've already got that a in that particular formula, okay, for the plus one here, what you notice is that 2b then has to be whatever this middle term is, which is 5. So by implication, I get b has to be 5 divided by 2. And once I have 5 divided by 2 as being b, that makes my life easy because to find this part, it's b squared, which is just squaring this. So b squared is going to be 25 over 4. So if I want to complete the square of just this expression, what I have here is that I add on to it plus 25 over 4. And once I add on that completed part there, okay, the important thing is that I can go right back to this. And that's what completes this. So this is now completed the square, okay? But if I want to write it in its completed square factored form, okay, it would be the x plus, okay, because this is plus, that's plus, and it would be not the 25 over 4, but the actual b that you found, which is that value divided by 2. So 5 divided by 2, that quantity squared. And that would be its factored form. Again, this is what value completed the square was the 25 over 4. So let's talk about how I can apply this to some other equations. So I'm going to go ahead and get rid of these formulas here. Hope that doesn't bother you too much. I mean, I have them memorized, and hopefully maybe you wrote them down. If you didn't, I would pause and write them down because I'm going to keep constantly referring back to them. So let's say I have this problem, and it says complete the square. And now it gives me 4x squared plus 8x and it gives me that value. And it says, I want you to complete the square. So if I'm just completing the square here, there's an important part here. There's two ways that you can talk about this problem, and I'll show both of them to you. I'll open up another video, and we'll talk about a different method. But for this one particularly, what I want you to note is that when I went through and I had the a plus b, that quantity squared, and when it came out, it gave me this. It said a squared plus 2ab plus b squared. And what I want to talk about here is that the leading coefficient is a 1. So for us to properly apply this method, we have to have a leading coefficient of 1. And well, the problem is here is that I've got a leading coefficient of 4. So how is it that I'm going to take something that has a 4 in it and turn it into a leading coefficient of 1? Well, there's a couple strategies here. And one of the strategies is that I could just factor out the 4. But in this case, it's not really going to help me. So what I'm actually going to do is I'm just going to divide the 4 out. So if I divide this 4 out, 8 divided by 4, I'm then left with x squared plus 2x. Now what I can begin to do is now I can look at what's going to complete the square for this. Okay, so one of the most important things that I want to take a look at here, though, is that, I'm not going to divide out the 4. What I want to talk about here is that you would factor out the 4. When I factor out the 4, I'm left with the quantity of x squared plus 2x. Okay? And this 4 is just a multiplier, so it's not going to affect anything. It's okay if I have a 4 outside, if I have a coefficient with my completed square. But what I need to look at is what's inside here. And this is the x squared plus 2x. And that's now what I'm going to pull out and think about what completes the square for that. So I'm just going to pull this out for a second of x squared plus 2x. And again, okay, this is my a, so the a squared, so the x is my a. So therefore, 2b, okay, in that original formula up here, has to be equivalent to creating 2. Okay, so 2 times what gives me 2, and in this case, b then has to be 1, which then makes b squared, just squaring this term, and you get 1. So now what I'm going to do is I'm going to add into the 1. I'm going to add the 1 into this, okay? And when I add the 1 into that, what that then creates is that now I've got this factored expression of x plus 1, that quantity squared. Okay, and that's just for that. So bringing this all down with it, I end up getting that this is my completed square of 4 times the quantity of x plus 1, the quantity squared. And then that there is now my completed square. And I don't like to divide values out because you'll find out later that if you start dividing values out that it's going to make it harder for you. But dividing this by 4, or factoring out that 4 makes it a little bit, it keeps all your values intact and it won't change the picture of the function that you're originally dealing with. So I hope that this helps with completing the square for that one. So let's do another one. And this time let's talk about just one with a fraction in it. So let's say I have this 5x squared plus 3x, and I want to complete the square. So completing the square for this one, let me write a little bit bigger, 5x squared plus 3x. Okay. So what I can do is I can begin to write this as a problem that would involve a factoring. So what I'm actually going to do here is I would factor out a 5. And when you factor out a 5, okay, all you're going to do is to write what you have in here, okay? If I factor out the 5, 5 divided by 5 is x, 5x squared divided by 5 gives you the x squared. Now if I factor a 5 out of the 3, what I want you to note is all you have to do is 3 divided by 5. So that gives me 3/5 x, okay? So now what I have is that this and these two expressions are now equivalent. So to continue on from this, okay, I would just do this. So again, okay, just to complete the square for here, the 5 is just going to travel down with whatever I have. And you're left with, for this particular one, is that 2b must equal 3/5, okay? So I divide by 2 and you get b is equal to 3/10, all right? So continuing on with this idea that b is equal to 3/10, and therefore b squared must be equal to 9 over 100. And if I could reduce any of these, I would, but in this case I can't reduce it. So up here what I'm going to do is I'm going to write the 5 comes down, and this is then x squared plus 3/5 x plus, okay, 9 over 100, okay? So now that I have 9 over 100, now I can write this out in its factored form, and the factored form says take the a plus the b. You've already got the a as being your x, so this is 5 times the quantity of, so x, so it's a plus again, so it's plus, and I take the 3/10, and then I write that quantity as a square, and then that's my completed square. And again, I don't like to divide out the 5. I mean, you can divide out the 5, but later on, they're actually going to teach you not to divide that value out, and you're going to have to factor it. So why not just learn to do this with already a factored expression of factoring out this leading coefficient. The hardest part here might be getting with this, but it's very simple. If you're factoring out a number that doesn't go to another number, you just write it as a division problem. So for instance, okay, you take the 5 away. 5 divided by 5 is 1, and that's what goes there, right? 3 divided by 5 would give me 3/5, and that's what I put in there. Because when I multiply this back through, it's going to create that expression. So I hope that helps, but that's how you complete the square, and I hope that helps with any homework that you're doing.